All right, y'all. 4.1, moving into quadratics today. So we're just going to get back into the swing of how do we graph a quadratic equation today, right? So we're just going to graph some of these guys. We're going to find and interpret the max and min values for these guys, and then we're going to call it a day. But this whole chapter is going to be on these guys, so we're gonna keep revisiting this and keep exploring what quadratics have to offer. So real quick, let's get back into the swing of it with standard form. Okay, so standard form, ax squared plus bx plus c, where we always have a quadratic term, which is the squared term. Okay, but and then the optional pieces to this would be the linear part of the function, which is the bx, and the constant, which is the c. So these can take many forms, but the quadratics will always have an x squared part of them. Okay, so what do these look like when you get a picture of them? They look like a parabola. We haven't studied in Algebra 1 all of these terms here that I know of. I think we've studied the vertex, but everything else I don't know that we've studied. But we're going to get into a more specific definition of what a parabola is in this chapter. Not right now. Okay, we're going to start with the basics from Algebra 1, but we will get there. Okay, so let's go straight into it. Whenever you guys are asked to solve a quadratic, remember there's a number of ways to do that. We can graph them, we can factor them, because we want to know essentially where do they cross the x-axis. So for example 1, all they want you to do is just get a picture. Okay, they don't even care about us solving it. They just want you to get used to graphing these again. So a couple of things. One thing that I know about this, I know two things about this before I do anything, any kind of work. The first thing I know is that the constant will always give me my y-intercept. The reason for that is it's where the x is 0. So if you plug a 0 in, this goes to 0, this goes to 0, and I'm left with negative 3. Right? So I know that this happens. I also know that this is opening downward because my first term is negative. Okay, so whenever I see the first term is negative, I know it's going down. So that kind of helps me with my picture. Okay, so let's see what's happening to the right of that point that I know. Let's see what happens at 1. So if I plug a 1 into this thing, I get negative 2 times 1 squared, which is just negative 2. Negative 2 plus 8 times 1, which is just 8, minus 3, okay, which is equal to, I believe, 5. So my first point here that I'm exploring would be 1 comma 5. Sorry, why did I say 5? Forgive me, y'all. It's pretty early morning for me. Negative 2 plus 8 is 6. 6 minus 3 is 3. All right, so this is 3. I apologize for the mistake. So at 1, 3, we have a point. Okay, so let's see what happens here. This is opening down. I still don't quite... I'm guessing it's going to be doing something like this. And probably getting steeper as we go into the negative, but let's just try a 2 just to kind of see what happens as we keep going up. So if we do negative 2 times 2 squared, that's going to be 2 squared is 4, 4 times negative 2 is negative 8, plus 8 times 2 is 16, minus 3. Negative 8 plus 16 is 8, 8 minus 3 is 5. Hey, there's a 5. So we get 2 comma 5. Which is up here, starting to look like it's leveling out. Okay, so let's try to find our vertex, which could happen somewhere in here now, I think. If I plug a 3 in, I get negative 2 times 3 squared is 9, so that's negative 18, plus 3 times 8, which is 24, minus 3. So negative 18 plus 24 gives me 6. 6 minus 3 gives me 3. So again, here now I'm back to 3. So at 3, I'm at 3. And so voila, look, there, that must mean that the vertex happened right there, right? Okay, so and a couple important points, you guys, that I want you to make sure you get onto your graphs when you're doing this. I need you to get to the y-intercept, the x-intercept, I should say, intercepts, and then the vertex. I need those three things to show up. The vertex is just the high point or the low point, which you just found. And it looks like we need one more point here to find out where my x is. But we also kind of know where it is, because if that's your vertex, it's going to be somewhere somewhere, this looks like it was between 0 and 1. So this one should be between 3 and 4. So let's just plug in a 4 and see where we're at. Alright, and if I plug in a 4, I should be the same distance from this vertex as I was when I plugged in a 0, which would be at -3. Let's find out. -2 times 4 squared, 4 squared is 16, 16 times -2 is -32, 8 times 4 is 32, minus 3, so this goes to 0, and I'm at -3. So at 4, we're at -3. Okay, which makes sense with our symmetry there. Remember, this is the axis of symmetry. So we have the same thing on both sides of that. And there we go. We have our y-intercept, we have our x-intercepts, we have our vertex. I don't really know what these things are, but at least it shows it crossing the x. Okay, you guys give this one a shot. Again, how I start these, I know that I have something at 1. I know this is opening up. Let's see what happens to the left and right there. So if I plug in a 1, 1 squared is 1, 1 times 4 is 4, minus 8 times 1, which is 8, plus 1. 4 minus 8 is -4. -4 plus 1 is -3. So at 1, -3, I have a point. Okay. Then I might want to plug in a 2 because this thing is going up. So I need to find out, okay, since it's curving that way, I need to keep going to the right until I get to my vertex. So I plug a 2 in. 2 squared is 4. 4 times 4 is 16. 16 minus 16 is just 0. Plus 1 is just 1. So at 2, I'm at 1. Did I do that right? Let me just make sure. 2 squared is 4. 4 times 4 is 16. 16 minus 16 plus 1. Yeah, so at 2, I'm at 1. So look, I found my, that's cool. I found my axis of symmetry, my vertex. It's happening at 1 there. This is kind of a skinny type of quadratic. And I actually have my, so right now I have my vertex, I have my y-intercept, and I have my x crossing. So I actually could be done. If you want to see exactly how steep this thing gets, you can plug a 3 in, and that can kind of give you an idea, but this is my symmetry line. Once you find that symmetry line, it's nice because whatever happens on one side happens on the other. 3 squared is 9, 9 times 4 is 36, minus 24, 8 times 3 is 24, plus 1, that gives me 12, plus 1 is just 13, so at 3 we're at 13. So we're way up here, so this thing is getting really skinny. And we have something that looks like that. Okay, so that's 1b. Axis of symmetry, we've already talked about this. This is the line that goes through the graph of a parabola that divides the graph into 2 congruent halves. Okay, so this distance stays the same. The red and the green are the same distance no matter where you are. Right here, it'll be the same distance on both sides. That's what the axis of symmetry is. The vertex is the only point where the axis of symmetry will intersect a parabola. Okay, so the axis of symmetry always goes through the vertex. This line here always touches the vertex. Axis of symmetry. The vertex is the smallest point or the biggest point, so obviously that peak is going to be where the axis of symmetry is if it's the same on both sides, right? So that is the vertex. All right, the y-intercept, we know the y-intercept happens when you plug in a 0 for x. Okay, it's just the constant term. I've already reviewed all that. So let's go for the equation of axis of symmetry now. So this is very helpful if you don't want to guess about where this graph has a minimum or a maximum, because you do need to find that vertex when you're graphing. This equation of axis of symmetry is super important in finding that. So let's bring this back. We know that the axis of symmetry happens at -b over 2a. Okay, where a and b are referring to this equation here. So let's just get into trying one of these again. This is for the axis of symmetry. Okay, so we can always draw a line there. a dotted line, and it will show me a mirroring line, what happens on the function. So first, for example 2, let's find the y-intercept, which we always start with because it's easy. It's 6. It's given to us. All right. Then for the equation of the axis of symmetry, let's find where symmetry happens. So we're going to do negative b. b here is negative 10. So negative 10 over 2 times a, which is a is negative 5. Okay, negative 10 gives me positive 10. 2 times negative 5 gives me negative 10. So I have symmetry at negative 1. So at negative 1, there's a symmetry line. I know this thing is opening down. It says find the x-coordinate of the vertex. Alright, so if this is where the vertex happens on the axis of symmetry, I'm just going to plug in the negative 1 to see where we're at there. Okay, so if I plug in this negative 1, which I have on my chart, negative 1, so I have negative 5 times negative 1 squared minus 10 times negative 1 plus 6. Negative 1 squared is 1. 1 times negative 5 is negative 5. Negative 5 minus negative 10 would be positive 5 plus 6 gives me 11. So at negative 1, I'm up at 11. I guess I'm off my chart here. Okay, that's my vertex, so I know that this thing is starting there. And what's nice about that now is, since I have this guy, I can kind of tell what's happening on both sides, right? But we need to keep going to find out where this thing crosses x. Okay, so it shouldn't happen too far from here, but now we know what to plug in. We can plug in a negative 2. So we have negative 5 times negative 2 squared. I'm just going to say plus, because negative 2 times 10, negative 10 would be positive 20 plus 6. Negative 2 squared is 4. 4 times negative 5 is negative 20. Negative 20 plus 20 is just 0, plus 6 is 6. So at negative 2, I'm at 6. Oh, I already knew that. I already knew that one because that's where my symmetry happened. All right, so let's keep going to negative 3. So you really didn't need to do this because you had it with your symmetry. But let's keep going with negative 3. So negative 5 times negative 3 squared minus, I want to say plus 30 plus 6. Okay, so negative 3 squared is 9. 9 times negative 5 is negative 45. Negative 45 plus 30 is negative 15. Negative 15 plus 6 is negative 9. So at negative 3, I'm all the way down here at negative 9. Okay, so you just kind of connect that. Get something that looks like that. That means that if I go 2 away from this line on the other side, if I plugged in a 1, I should also be there. Okay, at 0, I know I'm at 6. If I plug in a 1, I would get negative 5 plus 10, which is 5, plus 6. Oh, sorry, it's not plus anymore, is it? I'm in the positive. So sorry, negative 5 minus, let me go back here. Negative 10 times 1, I apologize, is negative 10. So negative 5 minus 10 is negative 15 plus 6. There we go. That's my negative 9. So at 1, I am also at negative 9. Just checking that. Okay, so I know that I have roots between 0 and 1 and between negative 2 and negative 3, right? The roots, remember, happen on the x-axis. All right, so where it intersects that yellow line. So that's example 2. Now, the max and the min, you guys, don't even worry about this too much. It is important, but you already know it, right? Whenever a graph is opening down, like it is here, then the highest point on that graph, this is known as the max. It happens at the vertex. The vertex is found by using your axis of symmetry, plugging it back in. That's what we did to get our vertex. Okay, so it's the y-coordinate of the vertex is the max or the min. We must plug in the x value of the axis of symmetry back into the equation to find out where it happens. We know that if the first term is negative, it's going to be a max, right? Because it's going to open down, so that's a maximum. If it's a positive, it's going to be a minimum because it's at the bottom point, because the thing opens up if it's positive. That's what all that is saying. So example 3 says, does the function have a max or a min? Well, it's positive, right? The first term is positive. I know it's opening up, so I know that it has a minimum. Okay, so it then says state the max or the min. Okay, well, I know that the vertex happens on the axis of symmetry, so I'm going to start with my axis of symmetry. Negative b over 2a. Okay, so if I plug in a negative b, that would be positive. Here we go, negative 24. I'll just show you all the steps. Over 2 times 4. This is going to be positive 24 over 8. 8 goes into 24 3 times. So I know I have axis of symmetry happening at x equals 3. I'm now going to take that and I'm going to plug it back in to find out where I am on the y here. So 4 times 3 squared minus 24 times 3 plus 11. 3 squared is 9, 9 times 4 is 36. 36 minus 3 times 4 is, I believe, 72. Okay, plus 11. So 36 minus 72 is negative 36 plus 11 gives you, what does that come out to? If you add 10 to that, you'd be at negative 26, so this would be negative 25. Okay, so at negative 25, we have our minimum. Y equals negative 25 is the minimum. What is the domain and the range? Okay, well, look, guys, you can figure this out because you know it opens up. Okay, the domain is going to be all reals for all of these, so that's easy. The range is what they really want you to focus on. If it's a minimum and the minimum happens at negative 25, then it's everything above that. So it's the y values where y is greater than or equal to negative 25. So that's example 3, using the max and the min to find that. All right, let's continue on with a real-world problem, and then I'll let you guys get to it. So real-world problem, suppose a tournament that Eddie organizes has 120 players. The entry fee is $40. Each time he increases the fee by $5, he loses 10 players. Determine what the entry fee should be to maximize the value of the pool. All right, so for these, you guys, I know these can be a little bit complicated, but just like in the last chapter when you're doing systems, we're going to focus on specific parts of the problem. Okay, so we know that in order to maximize a fee or to get some maximum amount of money, we know that ultimately what happens is we take the fee and we multiply it by the number of players or students. Okay, so let's make equations for this. The fee, okay, the fee here, so suppose the tournament organizes 120 players. Entry fee is $40. So I'm going to look at that, $40. But then each time he increases the fee by, each time he increases the fee by $5, he loses 10 players. Okay, so the fee would be 40 plus 5 times however many times he decides to raise it. Hopefully that makes sense, right? So it's $40 plus 5 times however many times he raises it. So he raises it 2 times, so he'd be looking at a $50 fee, right? So that works for the fee. Now let's figure out the students. So I know that we're going to multiply that fee by the number of students. We start with 120, but then we lose 10 for every X amount of times that he raises that fee. Okay? So if we think about that in those terms, it's a little easier to set up. Now, they want you to turn this into a quadratic. So we're going to just multiply this thing out. Okay, so if I FOIL this out, remember FOIL, first, outside, inside, last. Okay, if we do that, we get 4,800 minus 400x. What is this? 5 times 1 would be plus 600x. Okay, minus 50x squared. Remember that when you multiply an x by an x, you get an x squared. So this is going to be quadratic in nature. All right, so when we combine like terms here and put this in standard form, we get negative 50x squared plus 200x plus 4800. Okay, if we're looking to maximize the value of the pool, and we know that this is a negative here, we know that this thing is a parabola that looks like that. Okay, we just want to find out where this happens. This is why these things are actually very useful in the real world. Okay, so where does this, because this happens all the time in business where we use these to maximize a profit or something. Okay, so where does that thing happen? Well, let's find our axis of symmetry. So negative b would be negative 200 over 2a, which is 2 times negative 50. Okay, so this happens at, so this is negative 200 over negative 100, which equals 2. Okay, so x equals 2. So it happens when x equals 2, but it says determine the phi. So we got to plug this 2 back into our phi equation. So 40 plus 5 times 2 equals $50. We have a maximum amount of value or profit for this when I charge $50 for the entry fee. Okay, so that's a real world problem, you guys. They'll have another one like that. Just remember that when you're setting it up, think about the core of what it's asking you, and then make an equation for each individual piece and FOIL them out to get your quadratic. All right, that's